Hi, we're working on the lab force over mass, and in it we're going to observe Newton's second law of motion. The beginning of the lab asks you to push your accelerometer using different amounts of unbalanced force and then summarize your results in a data table. So I've got my accelerometer over here, and at first I'm going to give the accelerometer a very small push. So therefore a very small amount of force. So here I go. Small force, small push. The acceleration, well, the jar didn't go very far. Now let me go back and give the accelerometer a slightly larger push, a little bit more force. Okay, so the jar went farther. And then last but not least, I have to give the jar a large push, a lot of force. And the jar goes even farther. So I can summarize my results on the data table here. A small push, well, the acceleration that I get is very little. So I'm just going to put in small amount of acceleration. For a medium push, I got a little bit more acceleration. So I'm going to put in medium. And then finally, when I gave the jar a large push, well, I got a lot of acceleration. So I'm going to put large acceleration. All right, the next part of the lab asks me to recognize that acceleration is directly proportional to force. How do my results support this observation? Well, if I supply a little bit of force to a particular mass, I get a little acceleration. Little force, little acceleration. If I increase the force on the same amount of mass, I increase the acceleration. So the force applied as it increases acceleration. Now, instead of changing force for the second half of the lab, I'm going to change the mass. How am I going to do that? Well, I'm going to do that by changing the number of jars that I have. The instructions ask for you to apply force using the back of your little finger. Why do that? Well, it's difficult to be too forceful with the back of your little finger. And, if all goes well, you'd be applying an equal amount of force each time. We want to keep the force constant. The thing we're going to change here is the mass. All right, so got my accelerometer here. I put my little finger on the accelerometer and I'm going to give it a push. So there's a push with the back of my finger. That's how far the accelerometer went. Now I'm going to increase mass. I've got a second jar that I put water in. I'm going to line it up. I was sure to dry off the bottom of the jar because water's sticky, and if there's water on the bottom of the jar, that's going to impede my experiment. Okay. Supplying the same amount of force with the back of my little finger, and yeah, I think I didn't give the equal amount of force. Let's see here. Let me try this again. Here we go. Okay, there's back of my little finger. Here's the second jar. Okay, that was definitely harder to push. And then I'm going to add a third jar. Yep, that's difficult to accelerate that. Let's go back to the data table. I was keeping the force the same, but I was varying the mass. For one jar, the acceleration was large. I could really make that jar slide across the countertop. Same amount of force, but I increased the mass by adding a second jar. So 2 jars, this time I only got a medium amount of acceleration. And then finally, with 3 jars, so I had really increased the mass but kept the same amount of force, this time I got a small amount of acceleration. So what does this mean when it comes to Newton's second law? Acceleration is equal to force divided by mass. That's the equation, but what does it really mean? Well, there's a couple ways that you could think of it. One way to think of it is that if you increase the force on a mass, the acceleration also increases. In other words, acceleration increases in direct proportion to force, and it decreases in inverse proportion to mass. Let's look at the equation again. If in the second half of the lab, I keep the force the same, but I increase the mass, the acceleration will decrease. All right,